Welcome back. In this segment, we'll venture inside the NGSB 990CE to identify its core components. This is essential for advanced troubleshooting. For instance, if you experience a gas error and you've already confirmed that your main gas and electrical supplies are perfectly normal, the issue likely lies with an internal component. To investigate, we must first access the interior. To begin, we need to remove the front cover panel. This will require you to carefully remove the main control knobs and the faucet levers. Once those are off, you can access the screws holding the panel in place. Let's proceed with removing the panel now. With the front cover removed, we can now see the internal workings of the steamer. A word of caution: when you set the cover aside, be very gentle. As you can see, the main selector switch and other electrical parts are still connected by their wiring, so place it down carefully to avoid any damage. The interior is logically organized into two identical, independent systems. Here on the left, we have the first burner system, which we'll call System 1. And here on the right, we have the second, identical burner system, System 2. Each system is a complete gas and blower assembly with its own dedicated controller. Let's take a closer look at the components of System 1, and remember, System 2 right next to it is exactly the same. The brain of this assembly is the electronic gas control. This module manages the entire ignition sequence. Attached directly behind it is the gas valve, which physically opens and closes to regulate gas flow. This steamer uses a forced air combustion system which is powered by this blower. The blower pushes air at a specific RPM into this component, the venturi. The venturi is where the gas and air are perfectly mixed together before ignition. The gas then travels to the burner, where you'll find these two crucial parts: the igniter, also known as the spark plug, which creates the initial spark, and the flame sensor, a vital safety device that confirms a flame is actually present and stable. Now let's look at the components that manage the water level. Deep inside the tank, you'll find the floating switch. Its function is simple but critical. It tells the unit if there is water in the tank. When the tank is empty, the float drops, closing a circuit. This signals a solenoid valve to open and let water in. As the tank fills, the float rises until it reaches the top, which opens the circuit and stops the water flow. This is precisely why water quality is so important. Water with high mineral content, over 100 ppm, will cause limescale buildup like this. This can cause the float to get stuck, leading to filling errors. Always use soft water to protect these components. Moving on to the safety and alert systems. This small component is the buzzer. It's a 220-volt device that generates the loud, audible alarm you hear during a gas fault. For thermal protection, the unit is equipped with safety thermostats. There are two of them, one for each burner system. If the tank overheats, perhaps due to a lack of water, the temperature will rise until it trips these thermostats, which will immediately cut power to the entire system to prevent damage. We also have the operating thermostat probe here, which is what regulates the water temperature to 85 degrees Celsius when you're using level 1. Finally, let's demonstrate how to remove a complete burner assembly for servicing. Crucial safety warning: before you touch anything, make sure you have completely disconnected the main electrical power to the unit. First, carefully disconnect the wire connectors from the gas control module. Next, using a Phillips screwdriver, remove the screw securing the module, and you can then slide the gas control off its socket. To remove the entire blower and gas valve assembly, use a 10mm wrench to undo the 4 bolts holding it in place. Once the bolts are loose, the entire unit can be carefully lifted out. With the assembly removed, you now have clear access to all its individual parts: the blower, the gas valve, the venturi, the graphite gasket, which ensures a tight seal, and of course, the igniter and flame sensor assembly. Now let's continue the disassembly even further to service the igniter and the main burner. To separate the igniter and flame sensor from the mounting pipe, you'll need to remove these 4 screws. With the screws gone, the mounting flange comes right off. Notice this graphite gasket underneath. This gasket must be in good condition and correctly reinstalled during reassembly to ensure a perfect gas-tight seal. And now for a critical detail, the orientation of the igniter and flame sensor. This positioning is not random. If you install them incorrectly, the unit will fail to ignite and will trigger a gas error. The rule is simple. The igniter is the probe located closest to the assembly's ground pin. Next, let's remove the main burner. We'll start by taking off this stainless steel cover plate. You'll see it's backed with heat-resistant ceramic paper, which acts as a heat shield. Removing this cover reveals the thick mounting flange for the burner itself. To extract the burner, simply undo these surrounding bolts. With the bolts gone, the main burner can be carefully removed for inspection or deep cleaning. When reinstalling everything, it is vital to ensure the correct spacing between the burner surface and the probes. The ideal distance from the igniter and flame sensor to the burner should be approximately 5 millimeters. This precise gap ensures the spark can effectively ignite the gas mixture and that the sensor can accurately detect the resulting flame. An incorrect installation, like this example where the probes are angled away from the burner, is extremely hazardous. This mistake will not only cause a gas error during startup, but it could also lead to a dangerous gas buildup or a sudden backfire upon ignition.